The last topic we're going to look at in this lesson is how we can apply the slope to linear approximations. And so the idea is that I have a point on some function f of x. And so if I have this point a corresponding to a y value given by f of a, and I already know what the slope of this tangent line is at this point. The question then becomes, what if I have some other point over here? Let's call it a plus delta x. So that means that the distance between these two x values is just delta x. Delta x is the change in x. Then the question is, how could I approximate this y value right here? So what we've got here is delta f, so change in f values. So there's actually a really clever way that we can do this, and we're going to start with the limit definition of the derivative. So we have f prime of a is equal to the limit as delta x approaches 0 of f of a plus delta x, that's this point over here, minus f of a, that's this point here, and that's minus f of a. So this point is f of a plus delta x, and this is f of a. So we have f of a plus delta x minus f of a, and so it makes sense then that that's going to be equal to delta f, the change in the f values. And all of that is divided by delta x, which is the difference between these two corresponding x values. So in this case we have f of a plus delta x minus f of a is equal to delta f. And so what happens is when delta x is small. What does that mean when delta x is small? Well, it means when we take the limit as x approaches 0. That's when delta x is small. When that happens, then we get f prime of a is equal to delta f over delta x. Now, if we need to find out what delta f is, if this is what we're looking for, then I can take this equation, f prime of a equals delta f over delta x, and we can solve it for delta f, and we get delta f equals f prime of a times delta x. And so that's where this first equation comes from. That's where that comes from. And the second part here, where delta f is the difference between those two, remember that's what we said here, is that these two were equal to each other. Your change in f is equal to the second f value minus the first f value. So we call this the tangent line approximation. And so what happens is, if we know the tangent line at this point a comma f of a, and we're needing to approximate a point that's not too far away from this on the curve, then we can use the slope of that tangent line to help us find an approximation for the new y value. So this is the point slope equation of the tangent line. It may look a little different than what we're used to seeing. Typically we write it like this: f prime of a times x minus a plus f of a. All they've done is written the f of a first, and what they've done is they said, you know what, since these two are approximately equal, since f of x is approximately equal to this, then because delta x is small, then we can use L of x, so that we can name this function L of x, and we can use that as an approximation for f of x. And so that's where this equation comes from.